everyone, I'm Agya Dahal and I have come up with the third video on the analysis of structure. As you can see here, today I have come up with a beam which has got a link BD. In order to analyze any structure, first of all we need to determine whether it is statically determinate or indeterminate. For this, I have got a simple method. The end A is fixed, so it has got 3 reaction components. The end E is hinged, so it has got 2 reaction components. So 3 plus 2 is equal to 5 reaction components. The total number of equations of equilibrium is 3, that is sigma h is equal to 0, sigma v is equal to 0, and sigma m is equal to 0. Since the link has got 2 internal hinges, it has got 2 conditional equations of equilibrium. So 3 plus 2 is equal to 5. As 5 is equal to 5, the structure is statically determinate. If you find this method confusing, you can use the formula, which is 3m plus r is equal to 3j plus c. I have explained the uses of this formula in my previous video, so you can refer that. For analyzing the structure, first I need to draw the free body diagram by splitting the members. First, I'll take the member DE. So, DE, I'm assuming upward forces are positive and downward forces are negative. Now, if I take the moment about the point D is equal to 0, I'll simply get VD as 0 because there is no external reaction. Since VE is equal to 0, since VE is equal to 0, I'll simply get VD is equal to 0. I think I don't need to explain this. Now, HD minus HE is equal to 0. So, HD is equal to HE. Now, I will take BDE member. So, BD and E, BD and E. This is 0. This is 2 kilonewton. This is 4 meter. This is 6 meter. And this is 5 meter. And this is 4 meter. So, HE. So, this HB and this is VB. Since VE is equal to 0, we simply get VB is equal to 2 kilonewton upward. Now, I'll take the moment about the point B is equal to 0, and I'm assuming clockwise moment is positive and anti-clockwise moment is negative. So 2 kilonewton gives clockwise moment 2 into 4, and this HE is giving anti-clockwise moment minus HE into 4 is equal to 0. Thus, HE is equal to 2 kilonewton. So, we get HB also is equal to 2 kilonewton. Now, I'll draw the free body diagram and find out the reaction component HA, VA and ME. So, this is 2 kilonewton we got. This is 0 we got. And this one is 2 we got. This one is 0 we got. Since this is hinge, it has got its opposing signs. So this will be 0, this will be 2. And I got this as 2 kilonewton and this as 2 kilonewton. So this will be 2 and this will be 2. Now in the member AB, I have got this as 2 and this as 2 kilonewton. It is simple, and since it is giving 2 and this distance is 5 meter, it is giving a clockwise moment of 10 kilonewton meter. To balance this, we get anti-clockwise moment of 10 kilonewton meter. Now I'm done of finding out the reaction. Now I'll move on to drawing the bending moment diagram, shear force diagram and axial force diagram. The BMD, SFT and AFT of this BD and AB is simple. But BD is not simple because the member is inclined. So what we need to do? First of all, we need to find out the reaction components which are parallel and perpendicular to the member axis in order to find out the axial force diagram and shear force diagram respectively. For that, first of all, I'll find the angle theta. So theta is equal to tan inverse 4 by 10, which gives me value of theta as 21.801 degrees. Now I will resolve this theta. I will resolve this 2 kilonewton load into its respective parallel and perpendicular components. Since this is 21.801 degrees, this will also be equal to 21.801 degrees. So this will be the cos component. Hence I am taking cos, and this will be sine component. Thus I have taken sine. Now this 2 kilonewton load, which is acting in the horizontal direction, it will also have its parallel and perpendicular components with respect to the member axis. So since this is cos component, and this is sine component, we can take 21.801, which is vertically opposite angle. So this is trying to push the member, so it will push it downward. So it will be sine component, and it is in the downward direction, and this one will be cos component, which is in the upward direction. Similarly, this 2 kilonewton reaction will also be resolved likewise, and we got sine and cos components respectively. Here is 0, so no need to resolve, and here is 2 kilonewton leftward. So we resolve this and we get the respective values. Finally, what we got is, in the end B, we got 1.857 in upward direction and 0.743 in downward direction. So its resultant will be 1.114 upward. This is simple because there is no reaction components of this 0 kilonewton load. So this will only be the final reaction components. So we got it. Now I need to find the inclined length. I need to find this distance and this distance. For that, I'll use the concept of similar triangles. So I have used the concept and got the value of y as 1.6 meters. I'll use Pythagorean theorem to determine this length, from which I got it as 4.308. Now again I'll use Pythagoras theorem and I'll get the whole length, and we can subtract this and get the length as 6.462 meters. Now, as I have got all the respective reaction components, it is easy for me to draw the BMD, SFT and AFT. So first I will start with the member DE. So in the member DE, horizontal load 2 kilonewton is acting like this. So the axial force diagram will be negative, as these forces are trying to compress the member. There is no load, so the bending moment diagram and axial force diagram will be simply 0. Now coming to the inclined member, I'll rotate the member and make it horizontal. So this is B and this is D. So this D will be 0.743, and this will be 1.114. This is resolved and we got it as 1.857. This value is 4.308, and this is 6.462, and this will be 2.6, and this will be 1.857, and this is 0.743. So I'll draw the axial diagram first. So this 1.857, it is also compression, so it will be negative, and this is 0.743, which gives us 2.6, so this will be negative. So this is the axial force diagram. Now I'll draw the shear force diagram. This is 1.114, left upward will be positive, hence 1.114 upward, and this is acting downward, so it will go down 0.743, 1.857, and this will be 0.743. So this is positive and this is negative. So we got the shear force diagram as well. Now I need to draw the bending moment diagram. So for this is clockwise, and so it will be positive. So 1.114 into 4.308 will do. So this will give us the value 4.8. So this will be positive. If we take from this end also, we'll get the same value of bending moment diagram. Now I'm left only with the last member AB. So this AB has got 2 kilonewton load upward, 2 kilonewton load downward, and a horizontal force of 2 kilonewton here and 2 kilonewton here, and an anticlockwise moment of 10 kilonewton meter. Now drawing its axial force diagram is simple. It will be simply 2 kilonewton compression, and its shear force diagram, as this is left upward positive, it will go 2 kilonewton here and it will come here 2 kilonewton, so it will be positive. And this is the hogging bending moment, so the hogging moment 10 kilonewton will be downward, and since there is no moment here, it will be 0, so this will be 10 kilonewton meter. Now I will draw the whole combined shear force diagram, axial force diagram and bending moment diagram. So for that, the axial force diagram will be simply here 2 kilonewton, here it will be 2.6, here 2, here 2.6, here it will be 1.857, and here again it will be 2 kilonewton, 2 kilonewton. It will also be negative. The shear force diagram will be 2 kilonewton positive, and this one will be 1.114, and this will be positive, and this will be 0.743, negative. Here will be no shear force diagram. And the bending moment diagram, this will be 10, and this will be going like this, and it will reach up to 4.8 here, and it will end up like this, and here will be no bending moment diagram. So this is BMD, this is SFD, and this is AFD, which is the final one. So this will post in. I'm done with this video. Thank you for watching. Like, comment and subscribe.